Hello everyone, here we have to prove the gradient of 1 by r is equal to minus r vector divided by r cube. First of all, we have to know what is the r vector. Let r is a position vector. R vector is a position vector and position vector is equal to xi plus yj plus zk. And the gradient operator, as we know, the gradient operator is equal to del operator, and del operator is equal to partial by partial x of I plus partial by partial y of j and partial by partial z of k. Now we have to apply this gradient operator on 1 by r, and we have to know the magnitude of r vector. Here we can calculate the magnitude of r vector is equal to x square plus y square plus z square and power 1 by 2. Now we goes with our left hand side. Left hand side is a gradient of 1 by r, and gradient of 1 by r is equal to the gradient operator is partial by partial x into I unit vector plus partial by partial y into j unit vector, partial by partial z into k unit vector, and will be operated on 1 by r, and 1 by r is equal to x square plus y square plus z square and power minus 1 by 2. All partial by partial x will be operated on this x square plus y square plus z square power minus 1 by 2 separately, partial by partial x and then partial by partial y and then partial by partial z. First of all, partial by partial x will be applied on this, and then we will get the power minus 1 by 2 before, because it's a derivative of this whole function x square plus y square and plus z square power minus 1 by 2, the minus 1 by 2 and x square plus y square plus z square and power minus 1 by 2 minus 1, and the derivative of 2x, because the derivative of y square and z square goes to 0 with respect to x, and we will get here the derivative of x square is 2x, and similarly same with respect to y, we will get minus 1 by 2 into x square plus y square plus z square and power minus 1 by 2 minus 1, and now the derivative of y square will be equal to 2y, and here we will also get I unit vector, and here will be j unit vector, and plus again minus 1 by 2 and x square plus y square plus z square power minus 1 by 2 minus 1, and 2z and k unit vector. This 2 and 2y, 2 and 2x, 2 and 2y will be cancelled out, and the minus and x square plus y square plus z square power whole power minus 3 by 2 will be common, and we will get here the xi plus yj and zk. This x square plus y square plus z square is the r square, the minus r square, the magnitude of r square and power minus 3 by 2, and this whole xi plus yj is our r unit vector, r position vector, r vector. This 2 and this 2 will be cancelled out, and we will get r cube minus 3 minus r power minus 3 and r vector, and it will be written as r vector divided by r cube and power minus 1. Here we have proved that the gradient of 1 over r is equal to minus r vector and divided by r cube. Thank you for watching.